Hello everyone, my name is Shujan and today I'm going to be discussing the problem dragons, which is given by the question 230A. So let's quickly go through the question and what it says and what it wants us to do. So we have this player who's playing this game. So there's n dragons that live on each level, and these dragons have some particular strength. So both our player and the dragons have some particular strength, which is represented by an integer. So for a duel between our player and these dragons, it's determined by strength, uh, which for our player is given by S. So we're going ahead and the player, duels with these dragons, and it said that if the player's strength is not greater than the dragon's strength, then the player loses the duel and dies. Otherwise, uh, the player defeats the dragon and they get a bonus strength, which is denoted by yi. So they've given us a pair, which is xi being the dragon strength, and if they defeat the dragon successfully, we get a bonus strength of yi. So our player can fight the dragons in any order. Note, this is important. This is like a really big clue that they've given us in any order. I'll tell you why that is later. So we need to see if the player can move on to the next level and defeat all the dragons without losing. So quickly looking at the criteria, we've been given a time limit per test second 2 seconds. So we can essentially, we have a lot of time to uh, kind of brute force our way into this. So let's quickly look at one of the example inputs and compare it to the description that they gave us. So 2 and 2, here we have S and N, which is the strength of our player and the N levels. So we have the two being the initial strength and 2 being the number of levels. So each uh, line here is a level. And since 2 and 2, so we have the first dragon whose strength is 1. And since the initial strength is greater than the strength of the dragon, this means our hero obviously defeats this dragon very marvelously. And they gain this bonus points of 99. So after adding these bonus points, our hero's strength becomes 2 plus 99, which is 101. Then, if we go on and compare to the next level, which says 100 being the dragon strength and 0 being the bonus, our strength now, which is 101, is obviously greater than 100. So we can say our hero defeats the dragon and they pass all the levels. So we can say very confidently, yes, our hero lives to, see another day. But if we take another example, initial strength being 10 and there's only one dragon, but the dragon's strength is 100, we can obviously see that the strength of the dragon is much more than the hero. So our hero does not live to survive this. So this is a fairly simple question. Let's quickly look at the example that they've given us and going back to why they said they can fight in any order. So let's take this example again. If I had to write this down, let's say I switch the numbers such that it looks 100, 0, and 199. So if our player starts with the initial strength of 2, but if they encounter a dragon with the strength 100 on their very first turn, since their strength is 2, that means they cannot defeat this dragon and don't survive. But since they've told us that they can fight the dragons in any order, this means that we need to somehow sort um, how our hero fights dragons such that these bonus points add up to their favor and they can finally succeed and win. But again, we need to still have a sort of mechanism where we check the initial strength plus the bonus strength whether it can still defeat the dragon strength. And we need to check this for every level, and then if it outputs no, that means it might have failed at some level. If it outputs yes, that means it has passed all levels. and our hero can live to see another day. So I guess that's why this problem is 1,000 rated, because of this fighting in any order, which makes things a bit complicated. And the examples they've given us are very cleverly placed, such that they're already sorted. So if you were like me, I would have first, I initially went with just taking the input and, checking the sum and doing it. I forgot about the fighting in any order part. But then, if you would have submitted that, you would have gotten wrong answer, and you would have had to spend time thinking where I went wrong. And obviously, you'll have the mental impact of getting a wrong answer during a competition. So, with that, let's really, let's jump onto the code and see what the code looks like. So I've taken two integers known as initial strength and levels, which make it easier for me to track instead of S and N. So I'll show what that looks like. So I taken the input, and I found out that there's this very convenient data structure called pair that exists within vectors that does exactly what we want. So it takes in uh, the values as a pair. So it's a set of two, and we can really do this without using two variables such as I and j. So that doesn't really increase the time complexity as much. We just need one variable I, and the first and second elements are represented by dot first and dot second. Note these aren't functions, so there's no brackets. It's just dragons of I dot first and dragons of I dot second. So we're going ahead and taking this as the input for dragons. Then we're conveniently using the sort to sort pair, our vector pair. So essentially, we're sorting just on the basis of the first element and not the second element, which is again really convenient for us instead of uh, taking a 2D array and then trying to sort only on the basis of the first elements and then matching the first element with the second element, because you can't mix up the bonuses. So having this vector pair really makes life easier. So after sorting, we go ahead and we check the condition that we have, which is while we're checking for all the levels, which is given by n, or levels in my case. So we're checking if the initial strength is less than or equal to dragons of first, which is dragons of I dot first, which is essentially the strength of that particular dragon. So if at any point this breaks, we say no, and then we return this function, which means we don't need to run it any further, and we don't need to check it any further. If this is not true, then our hero's initial strength gets an added bonus of that particular dragon, which is represented by dragons of I dot second. So this loop runs n times, which is not the number of levels. If this successfully runs, that means we get a yes, and we can go ahead and successfully say the player gets to live another day. So if we had to look at this example, without, but by reverse sorting it, which is 2 to 100 0, 199 instead of 2 to 199 100 0. So if we execute this, we can see that we get a yes, since we've gone ahead and sorted this successfully, and we've gotten a yes. So yeah, that's it. Right, the time complexity of the solution. Since we're essentially having three loops in the solution, one to take the input and one to, uh, you know, go ahead and check for our condition, and the third sort of hidden loop that we'll have is within the sort function. So both of these have a time complexity of O of n, because we're really checking for the number of levels, which is some arbitrary number called n, and same for this one, we're doing it for levels. But for the sort function that we're using, we'll have the time complexity of big O of n times log n. So since that is the biggest out of all these, that gives us for the whole algorithm, for the whole solution, a time complexity of big O of n times log n. So it's sort of an efficient solution as compared to using a 2D array where you need to have two loops I and j to get input and to also sort it. With that, that concludes the end of the solution. Hope you liked it. If you have any feedbacks, if you have any questions, please do let me know. And have a good day.